k-variable linear stochastic model. So the linear stochastic k-regressor model, or it is also called k plus 1 variable model, because there is k number of explanatory variable and one explain variable, that is y variable. That is why k plus 1 variable model. Now in the first stage, yi is a function of, that means yi is explained variable, that is y denoted by yi, and x are explanatory variable, so y depends upon x. Here k number of explanatory variable that can show in this way, that yi is equal to f of x 1i, x 2i, x 3i, x 4i up to xki. With parameter beta, we can write it yi is equal to beta naught plus beta 1 x1i, beta 2 x2i, beta 3 x3i plus beta k xki. So here I is running from 1 to n. There is parameter is also k plus 1, because beta 1, beta 2, beta 3 up to beta k, here also one another parameter, that is beta 0. That is why k plus 1 number of parameter. And y1, if I equal to 1, then we can write it y1 is equal to beta naught plus beta 1 x11, beta 2 x21, beta 3 x31 plus up to beta k xk1. Similarly, y2 is equal to beta naught plus beta 1 x, here x x12 plus beta 2 x22 plus beta 3 x32 plus up to beta k x k2, and y3 is equal to beta 0 plus beta 1 x 1323 beta 1 is x 13 plus beta 2 x 23 plus beta 3 x 33 plus up to beta k x k3, and up to yn is equal to beta naught plus beta 1 x 1n plus beta 2 x 2n plus up to beta k x kn. In the matrix vector form, we can write it as y1, y2, y3 is equal to beta 0 common, that is why first column is 1 up to n, and x11, x21, x31 plus up to not plus, up to xk1. In the second row, 1 x12, x22, x32 up to xk2, and the third row 1 x13, x23, x33 up to xk3. Similarly, for last column, last row, we can write 1 x1n, x2n, x3n up to xkn, and beta 0, beta 1, beta 2, beta 3, beta k plus the error term u0, u1, u2, u3 up to un. And here we can write it as y is equal to x beta plus u x, the row is n number of row into column, and x matrix order is n into 1 plus k, n number of row and 1 plus k number of column. And similarly, beta has 1 plus k number of row and only one column, that is 1. U is the error term, here also n number of row but only one column. Our estimated equation is y hat equal to x beta hat, and least square method, that is OLS, CLS, LS, sum of the estimated square error must be, sum of the estimated square error means u minimum with respect to estimated error is ui hat is equal to yi minus y hat is equal to yi minus x beta hat, because they know that y hat is equal to x beta hat. Sum of the error square will be denoted by s is equal to u1 hat square, u2 hat square, u3 hat square up to un hat square. So s, sum of the square error s, is equal to u hat prime into u hat. The order is only one row and in number of column for prime case, and if u hat, then the order is n number of column and only one, n number of row and only one column. So u hat prime into u hat, we can write it as third bracket u1 hat, u2 hat up to un hat, and here only one row but n number of column, multiply with u hat, that is u1 hat, u2 hat, un hat, here n number of row but only one column. So if we multiply the terms, we get u1 hat square, u2 hat square, u3 hat square, un hat square, that can denote u hat prime into u hat. So y minus y hat prime into y minus y hat. Here we know that y hat equal to x beta, so put the value y minus x beta prime into y minus x beta. So in the next line, y hat is equal to beta hat x beta, sorry, y prime minus beta prime x prime into this is in the first bracket and multiplied with y minus x beta. So if we multiply both the values that is are in the first bracket, we get y prime y minus y prime x beta minus beta prime x prime y plus beta prime x prime x beta. So y prime y is equal to y prime x beta hat plus beta hat prime x prime x. So y prime y is equal to y prime x beta plus beta hat prime x beta minus beta hat prime x prime y. So in the subscript, consider the this is a matrix, that is why consider the order row into column. So y hat has one row and n number of column, y prime has one row, n number of column, y has n row, one column, y prime again one row, n column, x has n row, 1 plus k column, beta hat has 1 plus k row and only one column. Similarly, beta hat prime has one row and 1 plus k column, and x prime has 1 plus k column, 1 plus k row and n number of column. X has n number of row and 1 plus k number of column. Beta has 1 plus k number of row and only one column. Similarly, beta hat prime has only one row and 1 plus k column, x prime has 1 plus k row and only n number of column, and y has n number of row and only one column. So s is equal to y prime y minus 2 beta hat prime x prime y plus beta hat prime x prime x beta, since y prime x beta hat and beta hat prime x prime y both are scalar, that is why y prime x beta hat prime is equal to beta hat prime x prime beta hat prime x prime y. So first order condition, that is equal to 0, maximization condition, del s by del beta hat is equal to 2x prime y plus 2x prime x beta is equal to 0. So ultimately we get beta hat is equal to x transpose x inverse x transpose y. Pre-multiplying both the equation by x transpose x inverse and get x transpose x inverse x transpose y into beta hat is equal to x transpose x inverse x transpose y. So we know A inverse A is equal to I, identity matrix, that is why I into beta hat is equal to x transpose x inverse x transpose y. So beta hat well s is equal to x transpose x inverse x transpose y. Now we want to see that whether the estimated parameter beta hat satisfy blue property or not. Since beta hat we know that x transpose x inverse x transpose y, so here C transpose is considered as x transpose x inverse x transpose y. Beta hat is equal to C transpose y. So x transpose x inverse x transpose is equal to C prime. So in the subscript they consider the order, that means x and y, sorry, column and row and column, and beta hat is equal to C prime x is it C prime y, y means x beta plus u, so multiply C prime x beta plus C prime u. So beta hat equal to x transpose x inverse x transpose beta plus x transpose x inverse x transpose u. So A transpose A equal to I, that is why only beta is there, plus C transpose y, because we know that the C is x transpose x inverse x transpose. So beta hat minus beta is equal to C transpose u. From 1 and 2 we can say that beta hat is linear with u. U means error term and y, that is explained variable. Taking expectation both side in equation 2, that is expected value of beta hat is equal to expected value of beta plus expected value of C transpose u is equal to expected value of beta is equal to beta plus C transpose expected value of u, it's equal to beta, because we know that the expectation of a stochastic part is equal to 0. So expected value of u is equal to 0, null. By assumption beta hat is unbiased estimator of beta. So dispersion matrix of beta hat or variance covariance matrix of beta hat can be expressed as root beta hat is equal to expected value of beta hat minus beta into beta hat minus beta transpose. So in the matrix format we can show it expected value of beta naught hat minus beta naught, beta 1 hat minus beta 1 up to beta k hat minus beta k. This is a 1 plus k number of row and only one column, and it's multiplied with beta naught hat minus beta naught, beta 1 hat minus beta 1 up to beta k hat minus beta k, only one row but 1 plus k number of column. So and beta k hat minus beta k into beta naught hat minus beta naught. this hat and this hat will not. So ultimately beta k hat minus beta k into beta naught hat minus beta naught up to beta k hat minus beta k whole square. And then we take expectation and get this matrix. I am not going to explain, but the variance term will be square and the other term, that means this term, this term, this one, this one, this and this are the covariance term, and the square terms are, these are the variance. So already mentioned here, variance and covariance matrix represent, and the order is 1 plus k into 1 plus k. The whole variance covariance matrix is order 1 plus k number of row and 1 plus k number of column. So variance covariance matrix, it's represent that expectation of beta hat minus beta multiplied beta hat minus beta prime, expected value of, we know that beta hat minus beta is equal to c prime u, expected value of c prime u into c prime u prime whole prime. It's these two terms are in the expectation, that is the expected value of c prime u prime c and c prime into expected value of u prime into c prime. We know that the expected value of u prime is equal to sigma u square. This is a spherical model, that is why sigma u square into I, identity matrix, into c. So sigma u square into c prime is, we know that x transpose x inverse x transpose, and c is x into x transpose x inverse, because c is, so from that term c transpose whole transpose equal to c, that is c transpose means x transpose x inverse x transpose. If we take whole of transpose, then we get this value, this term, x multiply x transpose x inverse, and then finally get sigma u square I x transpose x inverse, and there is some formula is there, a b transpose equal to b transpose is a transpose whole transpose is equal to a b whole transpose equal to b transpose into a transpose, and a inverse a is equal to, sorry, a b inverse is equal to b inverse multiply a inverse a is equal to a transpose a, x transpose x inverse x transpose a, x here x transpose x inverse is considered as a inverse and x transpose x is considered as a, and c is equal to c transpose whole transpose, that means c, and x transpose x inverse x transpose prime is equal to c. I already mentioned that C transpose whole transpose is equal to C, so it's equal to X transpose X inverse, because X transpose X inverse whole transpose get the same value X transpose X inverse, but X transpose whole transpose is get only this term X, and then x transpose x inverse x transpose ax is equal to a inverse a is equal to I. This is the identity matrix. Let us see variance of beta hat is minimum or not, so check it. Let us consider another alternative unbiased estimator, that is b is equal to c tilde transpose y, c tilde transpose is equal to c tan c, c c prime plus d prime not equal to 0, so b is equal to c tilde prime first bracket x beta plus u, that is actually equal to y, so c tilde transpose x beta plus c tilde prime, so not transpose, that will be prime. C tilde prime x beta plus c tilde prime u. So expected value of beta is equal to b is equal to beta if and only if c tilde transpose x is equal to 1. So expected value of b is equal to beta, expected value of b is equal to c transpose or c prime x, expected value of beta plus c tilde prime expected value of u, c tilde prime x beta plus 0. Here c tilde prime x is equal to 1, so we get expected value of b is equal to beta. And c tilde prime x also called identity matrix I. And c tilde c prime plus d prime multiplied whole multiplied x is equal to identity matrix. So if we multiply x with the two value, c transpose x plus d transpose x is equal to I, x transpose x inverse x transpose y plus d transpose x is equal to I, x transpose x inverse x transpose x plus d transpose x is equal to I. So x transpose x whole inverse x transpose x, it is identity matrix, that is we represent here by this value I plus d transpose x is equal to I. So x transpose x inverse x transpose x is equal to A inverse A is equal to identity matrix I. So c prime x is equal to 0 and x prime equal to 0. Now sum of double summation expected value of beta b minus beta prime is equal to expected value of c tilde prime u, c tilde prime u transpose is equal to c tilde prime expected value of u prime into c tilde. And we know c prime plus d prime is equal to sigma I square, because c tilde prime is equal to c prime plus d prime. And this is a spherical model, that is the expected value of u prime is equal to sigma u square into I into c is equal to c plus d, c tilde equal to c plus d. So it's equal to sigma squares multiply both the first bracket term, that is c prime plus d prime into c plus d, it's getting the value. And ultimately if we multiply and put the value of c prime, then finally we get sigma square equal to x transpose x inverse x transpose x into, these are the x term, that means x transpose x inverse x transpose x transpose x inverse plus x transpose x whole inverse x transpose into d for this value. And for this the third term d transpose c means c prime whole prime, that is equal to x transpose x inverse plus last term d transpose d, sorry d prime d. And ultimately getting the value, because x transpose d and d x transpose is equal to 0, that is why second and third term is equal to 0. So ultimately get the value sigma square x transpose x inverse plus sigma square d transpose d. So we can say that the variance b is greater than variance beta hat. So beta hat has minimum variance unbiased estimate, its follow blue property.